So hello and welcome to Smart Study. Today again I am back with another circuit problem, sir. So before starting, don't forget to give thumbs up to this video. So let's start. Here we have given the question as in the following figure. Here C1 and C2 are the ideal capacitors, and C1 has been charged to 12 volt before the ideal switch S is closed at t equals to 0. So the current IT for t is what? So here we have given one circuit diagrams, and here we have to calculate the current IT for all t. And so the very first step that we are going to do is converting this circuit into S domains. So if you convert this circuit into S domain, we can write it as here C1 is charged to 12 volt. So first for 2 volts voltage source we can write since voltage source is converted into S domain as 12 upon S, and again we have one capacitor C1, and again here we have another capacitor C2. So to convert the capacitor into S domains, we can write 1 upon S C1, and similarly for C2 it can be written as 1 upon S C2. For C1 it can be written as 1 upon SC1, and for C2 it can be written as 1 upon SC2 in S domains. And if we apply KVL to the circuit, so if we apply KVL to this circuit, we can write here 12 upon S plus this is into, now this and this are in series, so is into 1 upon SC2 plus 1 upon SC1, and that will be equals to 0. So here from the here we can get as is equals to minus 12 C1 into C2 upon C1 plus C2, and this is going to give a constant value. So let us assume this gives a k constant value, and right now this is in the S domains, and if you convert it into time domain, then we can write as IT is equals to k into del t. It means the current IT is an impulsive function. So from this you can calculate that the current IT for all t is an impulsive function. Thanks for watching this, and please don't forget to subscribe to my channels for more exciting videos. Thank you.